wondered if there was an amazing product, so flawless, so utterly perfect, that it could manage all of your day-to-day tasks? Neither have I. But that's why I'd like to present you with my new revolutionary product, Mathlicious Trig Posters Deluxe. Larry? Thank you. That's right. That's right. These posters will change your life for the better. And all for the low, low price of $49.99 each, plus $29.99 for each transformation. Let's hear it for some of our satisfied customers.
How do you like your Mathlicious Trig posters?
My brain hurts.
I really hate...
G sharp,
G sharp,
A, B, C.
And how about you?
I feel smart.
You see, everybody loves Mathlicious Trig posters. We've interviewed 15 people, and all of them adore Mathlicious Trig posters. Now can you imagine how much you could like it? You know, let's take a look in our workshop, to see how Mathlicious Trig posters are really made.
Not again. I mean, I'll bet you'd like to see how I make these works of art. Well, I'll show you.
Gosh darn it, we forgot to pay the power bills.
First, I make a unit circle. I draw a circle, and I plot the points 0, pi over 2 radians, pi radians, and 3 pi over 2 radians. Like so.
Wow, that's amazing.
To begin this poster, I just graph the basic function of y equals sine of x. Now, as you can see, the points on the unit circle correspond to the coordinates on the sine graph. That means when there's 0 radians on the unit circle, y sine of x equals 0. When it's pi over 2 radians, sine x equals y equals 1. When it's pi radians, y equals 0. When it's 3 pi over 2 radians, y equals -1. And the cycle repeats itself as trigonometric functions are periodic. Then, I graph examples as to how different transformations of the trig graphs change the graph itself. For example, adding a coefficient before sine of x doubles the amplitude. So, when y of sine of x would make y equal to 1 for pi over 2 radians, now it equals to 2. When it's 3 pi over 2, it's y equals -2, and etc., etc. As you can see for yourself. Of my trig graphs, I just add a coefficient to x here. Now the period of a trig graph is equal to 2 pi over b, b being whatever coefficient is attached to x. That means that 1/2 x here would make the period more elongated. For example, when x equals pi radians, then y equals 1. When x equals 2 pi radians equals 0, to make a period of 4 pi.
You can see this Harvard PhD at work.
Now, for example, if I were to make a coefficient of x that was larger than 1, that would actually shrink the period, as you can see here. Now, since this is sine of 2x, that would make the period equal to pi. So, when x equals pi over 4 radians, y equals 1. When x equals pi over 2 radians, y equals 0. When 3 pi over 4, -1, and pi 0, to make a period of pi in a repeating loop. Now, occasionally I might, oh shoot. If requested, I can also do something to a trig graph called a phase shift, in which the graph shifts to the left or right. When it's negative, it shifts to the right, and when positive, to the left. Now, now I've made a phase shift here of to the right of pi units. And so the graph is shifted accordingly. as you can see, the normal starting point, which would be at the origin, is now at pi. Now I'm going to cover y equals cosine of x. Now, transformations affect both sine and cosine graphs essentially in the same way. However, there are a few notable differences to take into account. For example, cosine graphs correspond to the x-coordinates of a unit circle. So, when x equals 0, y is going to equal to 1. When x equals pi over 2 radians, it's going to equal to 0, so on and so forth for a period of 2 pi, just like y equals sine of x.
Okay.
Now I exemplify several transformations which I didn't quite cover in the sine graphs. Now as you can see, adding a coefficient before sine or cosine decreases the amplitude to like in this instance to 1/2, and making a coefficient to x which is larger than 0 shrinks the period like so. Now as you can see in this graph here, we have shifted the basic cosine graph to the left pi over 2 radians, and we shifted it up by 1 unit. Now this is a unique gem in the world of trigonometric graphs, the y equals tan of x graph. Now the reason why this graph is different is because the coordinates for the tan graphs are found by dividing the y coordinates over the y coordinate over the corresponding x coordinate on the unit circle. Interesting, I know. As you can see, the tan graph is periodic to pi, and the dotted lines, as you can see here, are the vertical asymptotes of the tan graph. These are the points where the tan graph increases exponentially to the point of infinity. Fascinating.
Wow, that was really exciting. But guess what? We've got an even more exciting offer for you right now. If you order in the next 10 minutes, we're going to give you something so amazing, it'll make your mind explode. It is a true artistic masterpiece, like so. What an amazing deal. But don't just take my word for it. Let's hear for some happy customers.
So, are you impressed with this amazing offer?
You bet I am. They're amazing. I'm gonna order me 10.
I need a drink.